A sperm whale dives to 2,000 meters and its lungs compress to the size of a grapefruit. Not metaphorically. Literally the size of a grapefruit. And the whale is completely fine. If that happened to you, your blood would turn into a deadly foam of nitrogen bubbles and you would be dead in under 2 minutes. The whale uses that same physics to stay alive for 90 minutes straight. Same ocean, same pressure. One creature dies. One creature thrives. The difference is so strange that understanding it will permanently change how you think about what a body actually is. Let's start with the pressure itself, because the numbers are genuinely unhinged. At sea level, the atmosphere presses down on your body at about 14 pounds per square inch. That is your normal. You do not feel it because every cell in your body is pushing back with equal force. Now at 2,000 meters of depth, that pressure becomes roughly 200 atmospheres. 200 times the force pressing on every square centimeter of your body. That is like balancing 3 adult elephants on your thumbnail. Permanently. On every single point of your skin simultaneously. Your lungs at that pressure would not just compress. They would catastrophically collapse. The air inside them would squeeze into a volume so small the lung tissue itself would tear. The nitrogen in that air would dissolve instantly into your bloodstream at toxic concentrations. The moment you came back to the surface, that dissolved nitrogen would explosively bubble out of solution, the same way carbonation fizzes out of a soda bottle when you pull the cap. Those bubbles would block blood vessels in your joints, your spine, your brain. That is decompression sickness. That is what kills divers who come up too fast from just 40 meters. The whale goes 50 times deeper and laughs at all of it. Here is the first piece of the answer. A sperm whale's ribcage is not rigid like yours. Its ribs are connected to the spine with flexible cartilage joints, almost like hinges. As pressure increases, the ribcage does not resist. It folds inward. The lungs do not fight the compression. They surrender to it completely. By the time the whale is at depth, those lungs are functionally empty, collapsed flat against the body wall. There is almost no air left inside them, which means there is almost no nitrogen available to dissolve into the blood. The whale sidesteps the entire decompression problem by eliminating the source. It does not manage the nitrogen. It removes the nitrogen from the equation before the dive even gets dangerous. But wait, if the lungs are collapsed, where is the whale getting oxygen for 90 minutes of active hunting? It brought it with it. Before a deep dive, a sperm whale loads oxygen not primarily into its lungs but into its blood and muscles. Its blood contains roughly twice the concentration of hemoglobin that yours does. Hemoglobin is the protein that carries oxygen in red blood cells. More hemoglobin means more oxygen storage capacity per liter of blood. And the whale's muscles are so saturated with myoglobin, the oxygen-storing protein in muscle tissue, that fresh sperm whale meat is nearly black. Not red. Black. Because the myoglobin concentration is so extreme it absorbs almost all visible light. If this just broke your model of what a living body can do, subscribe right now. Every week we cover biology and physics that textbooks bury in footnotes because they could not figure out how to make it boring enough. Now here is the second layer, and this one is weirder. The whale's circulatory system during a dive is not just carrying oxygen around. It is actively rationing it. The moment a sperm whale begins a deep dive, its heart rate drops from around 15 beats per minute to as low as 4 or 5. Blood flow to non-essential organs is selectively cut off. The digestive system, the kidneys, most of the peripheral circulation, all of it gets throttled down. Blood is rerouted almost exclusively to the heart, the brain, and the sonar organ in the whale's enormous head called the spermaceta organ. The whale becomes, physiologically, a stripped-down machine. It is running on the absolute minimum to keep the critical systems alive. But here is the detail that genuinely haunts me. Near maximum depth, the whale's blood itself partially fills the collapsed lung space. There is a network of specialized blood vessels in the chest called the rete mirabile, which translates from Latin as wonderful net. This web of interlocking arteries and veins acts as a heat exchanger and a pressure buffer simultaneously. As the lung space compresses, blood floods into the chest cavity to fill the vacuum. The whale is using its own blood as a liquid pressure equalizer. It is not just tolerating the physics of 200 atmospheres. It is actively exploiting those physics to protect itself. Your body cannot do any of this. Your ribcage is built to resist compression to protect your organs. That rigidity, which keeps you alive on land, becomes a death sentence underwater past a certain depth. The whale evolved in the opposite direction. Its body is built to yield. And yielding is what saves it. Now here is what this means for the frontier of science right now. Biomedical engineers are studying the rete mirabile and the oxygen storage mechanisms in cetacean blood as models for human trauma medicine. If you could engineer a hemoglobin carrier that stores oxygen the way a whale's blood does, you could potentially keep a patient alive during surgery without a beating heart for far longer than is currently possible. The whale solved a problem that human medicine has been trying to crack for decades. It solved it through 200 million years of evolutionary pressure, pun very much intended. The ocean is 2,000 meters deep in places we dive for recreation. The whale goes there as casually as you take a breath. And every time it does, it is running a masterclass in physics that we are still barely beginning to understand. The universe hid its most elegant engineering inside a creature that cannot even tell us about it. That is either the most beautiful thing you have ever heard, or the most humbling. Probably both. If you want more science that makes you feel like the universe is showing off, subscribe and hit the bell. Next video we are going inside a neutron star, where a single teaspoon of matter weighs 1 billion tons. See you there.